Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on equations. We're still looking at nature of roots, but now classifying that roots using the discriminant. Right? So I've gone through example of each one to give you an idea of if we ask the basic question, can you classify the roots? Right? So again, we need to know the table. When it's greater or equal to 0, the roots are real. If it's less than 0, non-real. If it equals a perfect square, it's real, rational, and unequal. If it equals 0, it's real, rational, and equal. If it's a positive number but not a perfect square, then we say it's real, irrational, and unequal. All right? So let's look at problem number 1. Classify the roots of the following. So they gave me x squared plus 4x plus 4. I need to know that a is 1 there. B is 4 and C is 4. So the coefficient of x squared, coefficient of x, and the constant. Right, so A is 1, B is 4, and C is 4. Now I'm going to substitute it in B squared minus 4AC. So my discriminant equal B squared minus 4AC. And I need to see what answer I get to classify the roots. So if I substitute, B is 4 squared minus 4, A is 1, C is 4, so 4 squared is 16. Minus 4 times 1 times 4 gives me negative 16. 16 minus 16 gives me 0. Right, so if B squared minus 4AC equal to 0, the roots are real, rational, and equal. So the roots are equal, rational, and real. Because it's equal to 0 based on our classification for the discriminant. Right, so roots are equal, rational, and real. Second problem, classify the roots. We have x squared plus 3x minus 4 equals 0. A again is 1. B there is 3 and C now is negative 4. Very important that we take the sign with the value. No? So if we substitute in the discriminant, b squared minus 4ac, right? B there would be 3 squared minus 4 times 1 times negative 4. Alright, so that gives me 9. That is positive 16. 16 plus 9 would give me 25. 25 is a perfect square. Alright, so again it's greater than 0, so therefore it is real. Right, it's a perfect square, so my roots are rational and unequal. Alright, so my roots are rational and unequal. It's real because it's greater than 0, but because it's a perfect square, it's rational and unequal. So hope you follow and you understand. Let's look at the third problem. So we have 2x squared plus 2x minus 1 equals 0. My a there equal 2. My b equal 2 and my c equal minus 1. Again, classify the roots. So we're going to substitute in b squared minus 4ac. Right, and if I put in there 2 squared minus 4 times 2 times minus 1. So there's 2 squared, which is 4. Negative 4 times 2, negative 8 times negative 1 gives me positive 8. 8 times 2 would then give me, now let's see, or 8 plus 4 gives me 12. Right, so I have 12. So again, it's a positive number greater than 0. Not? So the roots are rational. All right, but it's not equal to a perfect square. So we have real, rational, or not rational, irrational roots. All right. So the roots are unequal and irrational. All right, so I hope you follow and understand. All right, let's look at another problem. All right. So yeah, classify the roots. Right, okay, remember irrational roots can only be factorized by quadratic formula. So there, because it's not a perfect square, it's irrational, and so therefore if we factorize this equation, to get the factors, I'm going to have to use quadratic formula. Alright, look at the next problem. Classify the roots of the following equation, 4x squared minus 2x plus 2. So A is positive 4, B is negative 2. Please take the sign with it. And C is 2. Put in the discriminant, b squared minus 4ac. So b squared there would read negative 2 all squared, 4 times 2. So that gives me minus 2 squared minus 4 times positive 4 times 2. So that is positive 4, negative 2 squared, minus 16 minus 32 plus 4 would give me minus 28. Alright, now when the discriminant is negative, we're dealing with non-real roots, meaning we can't factorize it and it won't touch the x-axis when we're plotting or finding x-intercepts. Right, so my roots are non-real. Right, so I hope you understand and I hope you see how to classify roots. I try to do one of each, practice and work through your problems if they ask for classification. The next lesson, we're going to give you an equation, right? And you're going to have to find the unknowns if I state that. But in this case, these roots are rational and equal, rational and unequal, etc. Right? So that is the very important, a little bit more complex section. God bless. Bye.